Welcome back everyone. This is the second video in Tableau series, and let's recap what we'll be covering in this video. So in this video, I'll talk about different types of joins. Joins are very important topics because as a data scientist, often you work with more than one data set. So you need to know how to combine them, how to connect them together before you start your analysis. So I'll cover all the main types of joins in this video. Also, I talk about how join works when we have duplicate values, how we actually need to do joining on multiple fields. And the last topic is union, which is another types of technique that we use in order to combine different tables. So I'll talk about that as well in this video. In Tableau, you're not always going to work with just one data set. You'll often have different data coming from different sources. And so you really need to understand how to connect them and work with them all together. So in Tableau, we have two ways to go about it. So one way is to use joining, and the other option is to use blending. So before talking about how to perform joins and blending in Tableau, I thought it would be better to just review all the main types of joins to make sure that everyone is on the same level, and then I'll go back to the Tableau and show how you can actually do all these joining and blending and how it works in real life. So let's start to talk about what are the main types of join. We have 4 different types: the inner join, the left join, the right, and full outer join. Let's start with an inner join. So in this example, we have 2 tables. We have table A in color blue and table B in color green. So in table A, we have customer information. We have customer ID, which is a unique identifier which represents different customer that we have in table A. And also we have column, it's called customer name. And in table B, we have order ID, different information from different orders that has been made from different customers. So we have order ID, which is again unique identifier for different orders that we have in this table. We have customer ID and order amount. So what does inner join actually do? So an inner join combines records from 2 tables where there is a match in both tables, showing only the matched records. So that's why when you look at the Venn diagram here, you can only see the yellow color is in the middle, which is the area that are matched between the both tables, the table A and table B, which represents the 2 data set that we have here. So if you look at the actual tables here, we can see that the customer ID 2 and 3 are the only rows that are matched in both tables, A and B. So that's what we are going to keep in our final table. And obviously, the rest of the information or rows that are not matched in both tables, it will be removed. So the customer ID 1 will be removed from the table A, and also customer number 4 will be removed from the table B in our final table. And this is how our final table will be looks like if we use the inner join here. So we can see that we only have the customer ID 2 and 3 that are the only rows that are matched between 2 tables. The next types of join, it's called left join. So in a left join, what it does, it just returns all records from the left table and the matched records from the right table, and then filling in with null wherever there is no match. So again, if you look at the Venn diagram here, we can see that the blue color is used for the left table or table A. That means the goal is to keep all the rows from that, and also those rows that are matched in table B. So again, if we look at the both table here, we can see that the customer ID 2 and 3 are matched between them. So we have it in table B as well. And also because this is a left join, we're going to keep the customer ID 1 from table A or the left table as well. And the only row or information that will be removed is the customer ID 4, which is related to the table B or the right table, because the goal again is to record all the information from the left table, and those are matched from the right table. And then the final table will be looking like this. As I mentioned, those information that are not found on the right table will be represented as null. because we don't have any information about the customer ID number 1 in table B. That's why we actually use null here. So the next type of join, it's called right join. Right join is just the opposite of the left join. And so in the right join, the goal is to return all records from the right table and the match records from the left table. Again, filling in with nulls where there is no match. As you can see in the Venn diagram, we have the filled in blue color for the right table. That means the goal is to keep all the records from the right. And those that are matched in table A. So again, the customer ID 2 and 3 are the only one that are matched between the both tables. So we'll be keeping those information, and the customer ID number 1 will be removed from the table A or the left table, and we'll keeping the customer ID number 4 because that's a goal of using the right join. And our final table will be looking something like this. Again, we have no value for the customer ID 4 because we don't have any information about it in terms of the customer name and customer ID in the table A. And that's how it's going to look like. The final types of join, it's called outer join. And what it does, it just returns all records from both tables, matching where possible and filling in with null where there is no match. So the Venn diagram is it's actually filled in with blue color for both tables, for both circles A and B, because we want to keep all the records from the both tables. So the final table will be looking like something this. That shows all the information that we have from both tables, and those are that are null. That means we have like customer ID number 1 only in table A or on the left table, and and also we have column the customer ID number 4 only present in table B. That's why we have null values for customer ID and customer name. All right, now I want to talk about how we can apply joins, different types of joins, when we have duplicates in our dataset. This is something which is very common, and the thing is, sometimes the duplication that you have in your datasets are not because of an error. It's just the nature of that data, and I'll explain it in just a minute. So what happens? So now we want to talk about what happens when the column that we're joining have duplicates values. So we'll look at one example, and in this example, I want to actually apply an inner join between two tables. Let's say we have two different tables. Table A, again, it's the same as the previous example. We have all the information about the customers, the customer name, and customer ID. And we have a second table, it's called table B. And in that table, we have information about all the orders that has been made from different customers. But the difference here is that in table B we have duplicates. Like we have customer ID number 1, which have multiple orders, and also that same applies for customer ID number 3. We can see that it has 2 different orders, which makes sense because one customer can have multiple orders, right? One person can purchase different items in different day or on the same date. So this is very meaningful. It's not something that happens based on the mistake. So this is just the nature of this data set. And in these scenarios, we need to know how the joins actually can be applied and how it works. So now I want to explain about them. So we know that an inner join combines records from both tables where there is a match in both tables, showing only the matched records. So this is what you've learned previously. But the thing is, because we have duplicates in our table in our table B, so we want to see how this actually works. So, so when we use an inner join, what happens is when we join the two tables on the customer ID, which is a column that is similar in both tables, you can see that there will be two matches in the second table for customer ID 1 and the same for customer ID number 3. So what we know about the inner join is that an inner join combines record from two tables where there is a match in both tables, right? So we will end up having all the records that are matched from these two tables, A and B. So if we choose to do an inner join, whenever we have duplicates, what happens here is that the customer ID 1 with the name of customer John, it will be matched with the first and the second row of the table B, because these are all related to the customer ID and they will be matched together. So we will end up getting two rows that are related to the customer ID number 1. And for customer ID number 2, we don't have any duplicates in table B. So the customer ID number 2 in table A will be aligned with or match with the customer ID number 2 in table B. Also the same thing will be happens for the customer ID 3, because we again have duplicates of customer ID 3 in table B. So that means we will end up getting two rows of customer ID 3, and will be the last rows of a table A will be removed because we don't have any customer ID number 4 in table B. So that will be removed, and the final table will be something like that. So we can easily see that we have duplicates of customer ID 1 and customer ID 3 because, again, we had duplicates of them in table B. So for that reason, we have these duplicated rows of customer ID 1 and 3. And can see that we have all the information, all the columns from the both table. We have customer ID, customer name, customer ID from table B, and order ID and order month. All of them are coming from table B, and all the information related to each customers. This was just a quick explanation what happens if we have duplicates and we want to apply different types of join. This is an example of inner join, but the same concept will be applied whenever we want to have different types of join, like left join, right join, or outer joins. That's the same concept, but just a different joins. And the other concept that I want to discuss here is about joining on multiple fields. So normally what we have learned and what we have discussed until now, it was all about having only one column that are similar in both tables. Like, for example, on this example that I was explaining about duplicates in join, the only columns that were matched in both tables was customer ID. So we had only one columns that were matched in both tables. But sometimes in some projects, it is very common that you have more than one column that are similar in both tables. If you look at this example, you can see that we have, again, two different tables. Table A has three different columns: a store, order ID, and customer name. And in table B, we have four columns. We have a store, order ID, which are exactly similar to the table A columns. And in addition to these two similar columns, we have product column and order amounts. So this is something different, right? We have more than one column that are similar in both tables, and we want to see how the join is actually working here if this is the case. Now we want to see what happens if we do a left join only based on an order ID. So if we do that, what happens is an order ID number 100 in the first row of the table A will be matched with the order ID 100 in the first, second, and fourth rows of table B, right? And the thing is, if we look at it in more detail, we can quickly understand this is incorrect. These types of joins are incorrect because we are basically matching order ID 100 from the store A to order ID 100 from the store C in the third match here, which is incorrect, right? Because the stores are not different. One rows are coming from the store A, but the first rows in table B is actually coming from store C, so they're not related to each other, so it shouldn't be matched together. And the same thing applies for the customer store C and order ID 100, because again, if we only choose to do this left join based on order ID, the third rows in table A will be matched with the first, second, and then the third row of the table B, which again, it's incorrect because table C doesn't relate it to the store A and B, so they shouldn't be matched together. So this was an example to show you if we have more than one column that are similar in two tables, and we decide, and if we choose to do any types of joins based on only one of those, we'll end up getting mistakes at the end. So we really need to be cautious about it and always include all the similar columns that we have in both tables whenever we want to do a join, because this would happen for sure. But if we choose to do left join based on a store and order ID, in that case, we wouldn't have any problem. So if we do a left join, we will end up getting the match of a store A with from the table A to the first and the second row of table B, and then the second row of table A will be matched with the third row of the table B, and then the last row of the table A will be matched only with the last row or the fourth row of table B, and that's the correct way of doing joins or left joins in this example. And then the final result will be a table, something like that. So we can see that the right stores are matching, the right order ideas that are matching. So this is the way that we should do joins. The second technique that it's very important, we can actually do it in Tableau. It's called union. So union in Tableau is a method that used to combine two or more tables by appending rows of a data from one table to another. It's different than joins because in joins, we actually combine data based on matching value in a specific columns. But in union, we just basically stack table on top of each other or vertically, and we just add more rows to the existing table. And so this is one example that I want to show here. Let's say we have two tables. They're both like in union. The important thing is the tables should be similar to each other. We should have a similar number of columns, the similar types of column, and also the similar data types. If anything are different, so we cannot actually do the union. So if we have different columns or different number of columns in different tables, unions are not the type of joins or method that we need to use. So if we do the unions on this example here, we can clearly see that we have again the months and sales, and we have all the months. If we go back, we can see that in table A, we have months coming from January to March, and in table B, we have the months coming from April to June. And if you look at the final table, we can see we have all the months and all the sales related to a specific months here. So union just stacks table vertically, and we combine it easily if we have the similar structure of tables, similar columns, and similar data types. That's when we actually use union to easily combine them. And instead of having two separate tables, we have one clear table that we can import into Tableau and do any types of analysis. All right, so now it's time to show you how all these concepts work in Tableau and how to implement relationships, joins, unions. So let's just start with joins. I want to show that how we can do different types of joins in Tableau. The dataset example I chose for this part, it's called Amazing Mart EU2. I previously explained about this dataset, but I quickly explain about different sheets one more time. So in this data set, we have 3 different sheets, right? But before I start to explain about this data set, I just want to explain that you can find the link to access to all the data set that I am showing in this video in the description box. So you would definitely have access to all of them. So let's open this Excel file and explain what we have. So the first sheet is the list of order. So in this, basically in this sheet, we have a list of orders that have been conducted for different stores. We have order ID, which is a unique identifier, meaning each order ID is unique for that row and there are no duplicates and errors on this sheet. So the next sheet is order breakdown, which is the breakdown of each order based on products, meaning we can have one order with different products, categories, subcategories. So we have lots of duplicates of order ID in this sheet because orders can have multiple items in them. So it's pretty normal and it makes sense to have duplicates in this sheet. So the last sheet is called sales target, which we have months of the order date, category, and target. It basically gives us a target for 3 different departments: furniture, office supplies, and technology, and different months of the year. In the first sheet, we also have the order date if you look at the first column here, right? But that is not on a monthly level. In the last sheet, we have only months and the year, right? So we can actually conclude that the granularity is different between the first and the last sheet based on the date. The first sheet is more granular in terms of the date, but the sales of target is less granular. Also, as you can see that in the last sheet, we only have categories. So if you compare it with the order breakdown here, you will also see that the granularity of these two sheets are also different because the order breakdown is more granular than the last sheet, right? Because we have breakdown of each order and its corresponding product and all the subcategories information, but in sales target, we only have categories. So in total, we can conclude that the granularity of these sheets is extremely different across different sheets, and we need to pay very attention to them when we're trying to do joins or perform any other data operations. Let's say we want to create a dashboard for this whole data set, and our goal is not to just compare how the departments are meeting or not meeting their goals. So we cannot simply only use a last sheet. We need to find the best way to prepare this data for more complicated visuals and analysis. So we need to find a way to use all the sheets without losing any information here. So let's say what we should do if you face this kind of data set with different sheets and different granularity levels. So first thing first, first we want to create a new connection and connect to our Excel files. So here we can see that we have this section here that we can easily connect it to our Excel file. So I open it in the Tableau here. So once I open this, I can see my connection, the name of the Excel files, and all the sheets that I have under this file. So we have list of orders of breakdown, and sales target. And for this example, I just dragged the first sheet to the middle part of the page to have all the information about the data. So we have all the columns here. We have 10 fields and all the rows. So what I want to explain here, one thing that I haven't explained yet about this data source page is these sections here. So if you click on this area, if we click on that, we'll get to this page. Or not the page, but we get into that section, and we call this area as a physical layer. So the physical layer is where you can do the actual joins between table and where the structure of how data joins are specified. So we can say do the left or right join or outer join based on X column or Y column. So the purpose of this physical layer is to handle the actual data connection, including joins and unions. So we can do all types of joins and also unions in the physical layer by just clicking on this area. So if we click on it, we go to the physical layer and we can do all different join type, different types of joins and also union. So let's get back to the Excel file. I want to quickly explain one more thing. So as we discussed, our goal is to keep all the columns and fields to avoid any loss of information across all these 3 different sheets here, right? So when we look at the first 2 sheets, we can immediately realize that we can achieve this by performing an inner join between the list of orders and order breakdown sheets. So if we do that, we will have information about the customer names, the order the customer names, the order dates, all the orders made by the customer, what products were purchased, and so on. So we could we can easily combine these 2 tables by applying an inner join. We also can apply outer join, but the issue with that is if there is a row that is not available in one table, we will end up getting some missing values. So therefore, it's better to start with an inner join for this example. So now let me show you how you can do this in Tableau. So if we go back to the Tableau, let's say we want to do this inner join to combine these 2 sheets together. So we have a list of orders in this physical layer. So the only thing that I need to do is to just drag the order breakdown. And so if you put it under the list of orders, it shows like drag table to union. So in that case, you can do the union, but this is not something that we want to do right now. We want to do a join, an inner join. So in order to do that, we just need to go and put it just beside the list of orders. So if we do that, it's automatically do an inner join for us. But if an inner join is not something that you want to do, you can just change it by just clicking on the middle of the circle here. It just shows you all the other types of available join that you can do. So we have inner join, left, right, and outer join. But the inner join is the best joins that we can do for this type of example and this type of data set that we have. So we are okay with the types of joins that's already specified here. And we can see here, it says order ID. So this is shows us how this joins happens, like what sort of columns specified for this type of join. So it's an order ID. As you can see, we have order ID for the both sheets here, the order breakdown and also the list of orders. You can change it if you think that's not a correct one. You can change it to anything. Or if you want to add, or if you have multiple similar columns that you need to specify here, you can add it here. But for our example, we just have order ID column that are similar between these two sheets. So that's why we just need to specify order ID, and this automatically generated for us, so we don't need to do anything. The Tableau actually detect this already because they have a similar name, and Tableau can easily understand that. But sometimes we have similar columns with different names by mistake. So in that case, the Tableau mostly cannot understand, and we need to rename the column. And in that case, the Tableau can automatically detect it without need of any specifying here. So that's how we can do join in Tableau. Now let's talk about what we should do with the last sheet, right? So now we just combined the first 2 sheets here, but we haven't done anything for the last sheet, right? As we discussed, the granularity of the sales target sheet is completely different from the rest of the sheet and the combined sheet, right? The combined data that we have created is more granular, right? We have breakdown of each order based on a day, month, year and product details. However, in the sales target sheet, everything is rolled up based on category and the month. So this is very obvious. So I have created a few slides, a few PowerPoint slides just to explain exactly what's going on. So let's have a look on that slide here. So this is an example after we combine the first and second sheets, right? We have a list of order plus order breakdown. So that's what we will get after we do an inner join between the first and the second row. So we have all the so I actually chose this 3 dots here to just explain that we have more than what we actually see here, but in the real life we will end up getting all the columns from the both tables. So we have the order ID, order date, the customer name, etc., and also the product name, the category, and items. So in this scenario, when we think about this, the only way is to roll up by date and category. Like the only way to solve this issue is to roll up this combined table by date and category in order to match with this level of granularity of the sales target table. So basically we will lose information on order ID, on items, on rest except for date and category. And that would have been fine if the only thing that we wanted to compare is the total sales for a certain month and for a certain category to their target. But we can do that. Like our goal is different. We want to create a full dashboard. And for that reason, this is not the good solution for us. We cannot simply roll up the combined table and in that case be able to join it with the sales target table. So if I go back to the Tableau, and let's say I'm still in the physical layer and I wanted to drag the sales target to do a join between the combined table and the last sheet. So if I do that, the Tableau automatically chooses to do an inner join based on the category. It didn't detect the months, the order dates. So if you remember, we have most of the order dates in the last sheet, and the order and also the order dates after we combine the first and second and the second sheet, right? But because the name of the column are different, the Tableau didn't detect that. So that's why we can only see category. So this is another mistake. But the main problem is what happens here. So if I close this section, so what happens here is you can see that this is based on the category level. Like the Tableau picked an inner join based on category. And what happens here, it's just when this happens, it just creates duplicates of lots of rows, right? Because we have duplicates in the second sheet, if you remember, and then we combine them, the first and the second sheet. So we still have duplicates data, and then and if we do another join with the cell sheet, so we still get a lot of duplicates, which is a new whole mess, and we don't want to have that in our final data set. So this is a completely incorrect types of join, and we cannot do that. So I'll get this removed. So the question is, so what should we do in this scenario, right? What should we, because this is a very common issue. This is something that you would face for one time in your life. So this is a very common issue you will face definitely in one of your projects, and you really need to understand what are the best technique you can use for it. Thank you so much for watching this video. Please leave a comment below if you have any questions or you have any idea about this video, and subscribe if you found this video useful. Thank you so much, and I'll see you in the next video.